Hello everyone, class 12th, and the topic is name reactions in haloalkane. The name reactions are number 1, Wood's reaction, number 2, Horns-Dicker reaction, number 3, Finkelstein reaction, and number 4, Swart reaction. Let's start to understand every reaction. Like first I am starting with Horns-Dicker reaction. It is used to prepare RCl and RBr, means chloroalkanes and bromoalkanes. The conditions required are silver salt of carboxylic acid. What is the meaning of silver salt of carboxylic acid? This is the general formula of carboxylic acid. Now at the place of hydrogen, if we have silver with us, between oxygen and silver there will be ionic bond. This is known as silver salt of carboxylic acid. Now if you are reacting it with bromine and solvent is CCl4, carbon tetrachloride, CO2, carbon dioxide gas will release out. One Vr you have to join with silver and one Vr you have to join with R. RBr plus AgBr will generate bromoalkane. This is a simple technique to learn it. And if we need a chlorine there, so at the place of bromine you can use chlorine also. Let's understand this mechanism. What is the actual mechanism? The reaction is happening with free radical mechanism. The very first stage is actually chain initiation will start further, but the very first step is this. This particle will come in the contact of non-polarized bromine particle. Now due to electrons and positive charge, one bromine will have negative charge on it, one bromine will have positive charge on it. Now positively charged bromine will attack on silver, negatively charged bromine will attack on silver, and between bromine bond will break like this, both electrons will shift toward bromine, and that bromide particle will attack on silver, and positively charged bromine will attack on oxygen, and we will get RCOBr plus AgBr. Now this is an intermediate, acyl hypobromite. This is an intermediate we have. Now from this intermediate, chain initiation will start. Chain initiation step. This intermediate will create free radical. Oxygen and bromine bond will break like this, and one electron to each, because electronegativity is not so differ. So free radicals will generate like this. This is chain initiation step. This is acyloxy free radical. Now what is the next step? Chain propagation. Let's understand. Second step is chain propagation. In first step of chain propagation, this acyloxy free radical will start creating stable particles. Like O unpair electron will combine with carbon unpair electron and bond will break from here. So CO2, carbon dioxide, and carbon free radical will generate. This is one of the product, carbon dioxide we have. Now this R free radical will show second propagation step. it will attack on another, this one, intermediate particle, acyl hypobromite, RCOOBr, and bond will break like this. It will attack on Br, or Br will generate, and again you will have acyloxy free radical over there, or CO free radical. Now what will happen? We know it will repeat the whole cycle again like this. Acyloxy free radical was generated, it has created R free radical CO2, that R free radical attacked on another acyl hypobromide molecule. The same process will be continued there. So in this fashion we are getting RBr as a final product, carbon dioxide, and AgBr already we got in first step. Now chain termination steps you try by yourself. Already we have discussed this mechanism many a time. So this was the mechanism of Hunts-Dicker reaction. So if you have CH3 COOAg plus chlorine in the presence of CCl4, so simple technique, this is positive particle, this is negative particle. So one chlorine will make bond with silver, one chlorine will make bond carbon, and the CO2 you have to release out. So AgCl plus CO2 and CH3Cl will be our final products. In this fashion you can complete Hunts-Dicker reaction. Up to 12th level, mechanism is not in our syllabus. Next reaction, Wood's reaction. Very easy to understand. First let's check. It is used to prepare alkane from haloalkanes. RX means haloalkane going to react with sodium. Now it is very easy to understand that reaction. X negative because it is more electronegative than R. Same here, X negative, R positive. Sodium we know they are positive particle. From lower classes we know what is the valency of sodium, +1. So this is positive particle. I am not telling exact mechanism. I am just telling you the way in which you can understand that reaction, in the way in which you can learn it. Now positive negative particles will combine together. 2NaX will eliminate out, and what to do? RR just combine. This RR will be alkane. For example, CH3Cl, CH3Cl. If are showing Wood's reaction, this is negative, this is positive, this is negative, this is positive. These are positive particles. NaCl positive will attack on negative, so just break a bond. 2NaCl will eliminate out and combine these carbons. CH3 will generate ethane. In this fashion you can use Wood's reaction. Now what is the limitation of Wood's reaction? The limitation is we cannot prepare odd carbon alkanes. To understand it, first understand this one. 1 plus 1, 2. 2 plus 2, 4. 3 plus 3, 6. 4 plus 4, 8. 5 plus 5, 10. And so on. Every time when you are adding same number, even number we are getting as a result. And we know in Wood's reaction what is happening. Same number of carbon like CCl. So one carbon, they are combining to give us alkane. So obviously the alkane will be even carbon containing alkane. It is impossible to create odd carbon alkane. Let's try it and we will check what are the problems. What problems we will face if odd carbon containing alkanes we are preparing. Like I want to create 3 carbon containing alkane. So one molecule I am using CH3Cl, other molecule I am using CH3CH2Cl, and let's react them in sodium. So this is negative, this is negative, this is positive, this is positive, this is positive particle, NaCl you will eliminate out, you will combine them, and you will say CH3, CH2, CH3 is ready. 1 carbon from here and 2 carbons from here, ready. Propane. Okay, no problem, but wait. Problem is, this particle will show its own Woods reaction side by side. Like this. 2 NaCl, CH3, CH3. Check this. Ethane will be a side product there. Similarly, this chloroalkane will show its own Woods reaction side by side. NaCl will release out, they will combine to give us CH3, CH2, CH2, CH3. आपको यहाँ से जोड़ना है, इस कार्बन को इस कार्बन के साथ जोड़ना है, इस कार्बन को इस कार्बन के साथ, इस कार्बन को इस कार्बन के साथ जोड़ना है. तो चेक व्हाट वी गॉट, ब्यूटेन. तो विद प्रोपेन you will also get ethane and butane as a side product. Means mixture of alkanes we will get. Pure propane you will not get. You will get a mixture of alkanes which are generated due to their individual Woods reactions. These. Now this mixture is very difficult to separate because the boiling points of these alkanes are very close. We can't separate them very easily. So that's why Woods reaction is not preferred to create odd carbon containing alkanes. Let's go for the next reaction. SWOT reaction. It is used to prepare RF, means fluoroalkane, from RBr and RCl. Condition is very simple. RCl reacted with silver fluoride. Now Cl is more electronegative than R, negative, positive. Silver we know, positive. Fluoride will be negative here. So positive will combine on negative, negative will combine on positive. That's it. Double displacement type reaction it is. AgCl. RF is generated. Fluoroalkane. Similarly, we can use bromide. Bromoalkane, same, negative, positive. Here we know positive we have, negative we have. Silver has less electronegative than fluorine, but containing positive charge. So positive will attack on negative, negative will attack on positive. RF plus AgBr, fluoroalkanes. Again, I am repeating, these are not exact mechanism. They are just a techniques to learn these reactions, to understand these reactions quickly. That's it. Fluoroalkanes will be generated over here. And the last reaction is Finkelstein reaction. Finkelstein reaction. It is used to prepare iodoalkanes from RCl and RBr. Again, very simple to understand. RCl and you need sodium iodide here. RCl, Cl is more negative because electrons are toward chlorine due to electronegativity, higher electronegativity of chlorine. Carbon will get positive charge. Sodium we know positive, iodide will be negative. Again positive, negative, negative, positive. Ri plus NaCl as a side product. Same with bromide you can do. Nai, negative, positive, positive, negative. Positive will combine with negative, negative will combine with positive. Again Ri plus NaBr as a side product. One more point you have to note down here. Acetone will be solvent here. Now NaCl and NaBr, NaCl and NaBr are insoluble in acetone. These side products are insoluble in acetone. That's why they will precipitate out or settle down in the form of solid particles. So we can easily separate them out. During reaction, solid particles will generate and they will settle down, and we can easily separate them from a final product mixture. NaI is soluble in acetone. That's why it is able to show this reaction. The particles are breaking into part, cations and anions in acetone. That's why it is reactive toward RCl or RBr. But side products NaCl, NaBr are insoluble in acetone. That's why they will settle down in the form of solid particles, which we can separate very easily. That's it. These are the name reactions we have for haloalkanes. Understand them and practicize them through actual molecules. Like at the place of R, we can use cyclohexyl or any other alkyl group and try to complete the reactions. Thank you very much.